In this lesson, we'll focus on what it means to be linear. Hey, is that linear? So at the very beginning, you notice those on the left are linear. The graphs on the right, they're non-linear. So think about what you observe, if you can come up with a prediction. All right, here's the rule for linear. The definition is a linear relationship is a relationship between two variables that when graphed, they form a straight line. I hope you can notice in the word linear, the root word is line. That helps me remember these are things that are going to form a straight line. So you'll see the graph on the left, that's linear, it's a straight line. The graph on the right, it's curved, it's not linear. You can notice if something is linear if it's on a table form, because if a table is linear, when x changes by 1, the y value changes at a constant rate. So for example, in this equation on the left, you're going to see that x is going up by 1, 1, 1, 1, etc., and y goes up by 5, and then 5 again, and then 5 again, and then 5 again, so it has a constant rate of 5. It's linear. On the left, you can notice x is going up by 1, but as you look for y, well, it does have a pattern, it's a multiplying pattern, but you see the first time it adds 12, and then it adds 60, and then it adds 300. So it does not have a constant rate. It's not linear. If an equation is linear and it's not vertical, it can be written in the form y equals mx plus b. This is a pretty famous equation format, y equals mx plus b. So y and x stay variables, and m and b are numbers. In these equations, y equals negative 3x plus 5, it's in the right format. M is negative 3, b is 5. In y equals 0.5x is also linear. 0.5 is the m. You don't see the invisible b value, but you could add 0 without changing that. In y equals x minus 4, well, there's an invisible number of a 1 in front of the x, and minus 4 could be written as plus negative 4. These all follow the format. They're all linear. Non-linear, we can notice these couple on the right are not, because y equals 2x squared. The culprit that makes this one not linear is it has this squared in there, so it can't follow the format. Y equals 3 divided by x. The problem with this one is it's being divided by a variable, so that's not going to be a linear relationship. It can still have a pattern, but it's not linear. All right, I'd like you to challenge yourself right here. So in a lot of cases, you're given a table, but the x values are not counting by 1. Can you figure out if there's a constant rate? Go ahead and give this a try, and then I'll show you my typical techniques for this. Okay. I tend to still look for the change in y. So look here at 7 to 11, it's increasing by 4. From 1 to 3, it's increasing by 2. Okay, then I might look at another pair. So here from 11 to 15, it's increasing by 4, and here it's also increasing by 2. Okay, well, that has the same ratio here. Then if I look at the last one, 15 to 45, well, that time it increases by 30. But here from 5 to 20, it increases by 15. So there's something pretty cool that you can do. What you can do is divide your change in y divided by your change in x. So in this case, I would do like 4 divided by 2. Well, that equals 2. It would be going up by 2 every time if you changed it to 1. Here, 4 over 2, that's also 2. And here, 30 divided by 15, that's also 2. It actually does have a constant rate, and if x was counting by 1, y would be increasing by 2. Okay, last thing, I'd like you to pause the video and challenge yourself to go back through all the examples. Can you find any relationships that are proportional? Remember, to be proportional, a relationship has to be a straight line and go through 0, 0. So go back and see if you can find any proportional relationships in this lesson. By the way, I only found one. All right, I will see you guys in class.